Evening, guys. So, on my bench here is a collection of blown up FETs. Look at these guys. It's like we're in a pandemic right now, and it's like I'm throwing away gold, except they're FETs. These are the newest ones that I have, and these are the 4 that I blew up last week. So at $35 each times 6. Kind of pissed me off. What do we got? So 36, no, they're $39 each. So 39 times 6, $234. Garbage. So powering the amplifier up for the first couple weeks there, it was working great. Low voltage rails. I think it was running 25, 35 volt rails or something like that. It was working great. So I was like, you know what? Let's push this to 45 volt rails. I have this nice transformer over here. I have a nice capacitor bank that I bought off DIY Audio. Well, they're okay. I don't really like the boards, but they work. I bought them because I was building Aleph 2s and ditched that project because I lost my heat sinks in a CNC shop. So I abandoned that project a couple years ago and then started doing other stuff like the Elves and the Minis and stuff. And Gareth and I started working on this. So anyways, point of my video is I wanted to show you guys what I do and what I've been doing for many years and what my dad's taught me and others have taught me. All basically relative the same thing. How to power up an amplifier that is freshly built and not blow up your FETs. And I'll say it right now, the only reason why FETs blew up is because of high current turn on, and these are not designed for that. Nelson Pass uses these, I believe, in the XA25 lower voltage rails. We all know that that amplifier only puts out 25 watts, really good 25 watts. But I was trying to achieve 100 watts out of this, and I'm sure I could probably do it, but there's something I'm missing, and I just don't really feel like burning up other FETs. I did email Nelson, and he pretty much came to the conclusion that 45 volt rails is a wee bit much. So I have this amplifier working 32 volt rails, 60 watts output, RMS into 8 ohms. But today's video is I wanted to go through how I've got everything connected, what I do, turning on the variac slowly, what I'm watching for, and go from there. And then I was going to show you guys it running with a signal into it and it not blowing up, turning it off, turning it back on. Done a little bit of preliminary today and going from there. So first thing I want to do is turn down my variac because the amplifier's been running. Heatsink's back down to cold. There's no temperature on there. Turn on all the meters. 1, 2, 3, 4, 5. 5 meters, a scope, signal generator. We'll push the signal generator back down to 500 millivolts or 255 millivolts peak to peak. So we're not putting too much power into it. And then I'll show you what I do when I power up an amplifier very slowly and what I'm looking for and go from there. So give me a second, I'm going to grab my camera, flip it around, and I'll show you what I'm doing, and then I'll explain what I'm doing in the video. Hold on. Okay, I'm going to show the setup. So we got a meter here, set to DC, millivolts, to check the voltage across the source resistor, see how many millivolts of DC power we're going to have, so we can check our current. Right now I've got this board set to 300. The other side is wired up like this. Scope probe is on the speaker output with a bench meter, 1 kilohertz signal, 295 millivolts. The output is off, but I'm going to turn it on so that way we can turn on the amplifier slowly and see what is going on. Got a power supply to board here. Oh, we got 2 meters. We'll turn those on. And all these are doing is checking rail voltage with the variac set to 0. Pretty sure when I power this up, I'm going to go to 15 volt rails for now and test it. But what's been happening is the amplifier, when turned off and rail voltages are back to 0, turning it back on, it shorts the FETs and just blows the fuse. So we have a 5 amp fuse in there. I'm going to start off slow because I'd rather blow a fuse, but I'm pretty sure it's going to blow the FETs if this blows up anyway. So first things first, let's turn it on. The variac is down to 0. We got no voltage. And I'm going to be looking at this screen right here to see if there's any DC offset. And then I'm going to watch and see if this comes on. So let's do this slowly. 0, on, and we'll check 3, 4, 5. Let's go. I don't know why. We got an issue. Maybe not. Where's my little dial thing? Oh, okay, so 12, 14, 15. We're going to sit at 15 volts. 16. Okay. 5 millivolts DC out. And if we go to AC, we'll see that we got 4 VAC. Now if we go like this, this way, and we go like this, we have a perfect clean sine wave. We have 400 millivolts DC on the output, and no smoke, right? Is this getting warm? Probably not going to get too warm right away because this heatsink is stone cold, and we're only at 18 volts, right? So the next thing would be to, I don't think this thing's, yeah, it's warm. It's not hot though. Yeah, thermistor there now. So next would be to turn it off at the variac, wait till this dies down, and then turn it back on and see if it blows up. As we can see, we got a clean sine wave. There's no load into the amplifier. 400 millivolts per rail. Not sure how much current it's pulling right now, but it's probably not pulling much because I have really low voltage rail. Heatsink. It's getting, I could feel that it's coming up to temperature. It's getting warm. Yep. So I'm going to turn it off and wait a minute and turn it back on. And let's see if it doesn't blow up. Okay, so the amplifier is running. Haven't turned it off. Well, I turned it off, reset it to check current on the positive and the negative FET. So on this source resistor, we have still 1 kilohertz signal in, 4 VAC with a perfect sine wave, and I'm going to turn it off. It's off. So we'll wait about So the amplifier's off. Give it another maybe minute or so. And we'll turn it on and cross our fingers, right? Is this thing gonna autofocus? Maybe not. Oh well. Okay, so that was our max when we turned it off, 357 millivolts for our current across our source resistors. We have not much here, but I'm going to turn it on now and cross my fingers because this is my last set of FETs. Here's my set of FETs that I blew up this morning with 45 volt rails. And here we go. We'll watch this. If it blows up, I'll see what this goes to and see what the scope goes to. And we got a 5 amp resistor in, or 5 amp fuse in there, so I'm not gonna see any sparks, but it'll blow. So here goes to my last set of FETs. Here's 4. Here's 4 of my first ones. Sorry for the glare. There's 4 in there. These are all dead. And that's 6. Okay, here we go. Ready? And look, it didn't blow up. Oh, it peaked to 722. So at turn on, that's what it did. I don't know what this one peaked to, but it didn't blow up, so that's pretty cool. So 24 volt rails. My heart's still pounding. But that's okay, I guess, for now. So if there's no load on this right now, but if we go to this, before clipping, let's see what we get. Right, I'm gonna have to turn this down a little bit because it's not gonna reach that. So 7, 8, 9, 10, 11. No, right there. So we're getting 16 VAC. Not sure what that is when we put it into my simplified calculator right here. 16.5 times 1, 6.5 equals divided by 8. Yeah, we're at 35 watts. So I guess the next test would be to see what 32 volt rails would do. So let's slowly bring this up. 28, 29, 31, 32. Okay. And then let's go with this. What do we get now? Before clipping, holy crap, we're over 20. So 20, 23. So if I bring this over, that's hard clipping right now. Bad. So we're getting right there, 22.3 VAC. Okay, I'm going to turn it off and go from there. Okay, some more part of the video here. You've got 32 volt rails. I raised the bias a little bit more from 300 and change to, we're sitting at 491. And I put a fan on top because it's getting warm. Still running. No issues. I think the next test I'm going to do is I'm going to change the meter from millivolts to volts and then do a peak hold. So, and then turn on the amplifier and video it and see how much current it draws when it turns on. And I might do some math with 45 volt rails and what it's set to see how much current it actually is rushing in. And I'm pretty sure that that's what's going to blow up these FETs, even though they have a, what do we got? On, it's 88 amps. This is the original FET anyways. So, yeah. So I'm going to turn this off, change my meter, let it die down, and then we'll continue recording when I power back up. Hopefully no smoke still. Alright, some more to the video. This amp's been running since 7 this morning, running just fine. It is now 12:30. So, amplifier's running 32 volt rails. I'm going to call it 32. And right now I've been running it at 11 VAC consistently. So if we do the math on that, I'll go 12 because it's 11.93. So 12 times 12 is 144, obviously, divided by 8. It's sitting at 20 watts for the last 4 hours, 5 hours. So we could push this up till we get to clipping. And I believe we get to 1.2. 1.2. Yeah. About 19 VAC before clipping. A nice clean wave. I don't see any smoke. Amplifier seems happy and stable. Let's bring it back down because I don't need to sit here and waste all this power today. So if we do the math on that, what did we say it was? 19? 19 times 19 divided by 8. 45 watts. It's pretty good power on 32 volts. Pretty happy with that. So, on to the next part of the video. If we turn the output signal on, we're at 490 millivolts. I'll put the math into the video in a minute here. I got a 100 ohm or 100K pot in there, and it's maxed, so I don't really think I need to go any higher on the bias, but the amplifier is running. So now I'm just going to unplug all the test setup and play some music through it today. And in my next part of the video, you'll hear me listen to music. Building another board. So watching the video here, looks like the amplifier is running, but it's majorly oscillating for some reason, and I've narrowed it down to maybe not matched proper FETs in the front end or a bad FET. So tomorrow will be some more parts, and I'll be able to repopulate a new board to rule out anything else wrong, and I will be testing some more of the amplifier, and it looks like I should be able to post this amplifier to 45 volt rails without problems. A lot of people online have posted that your amplifier probably blew up because of oscillation, or oscillating, sorry. And I'm going to actually agree with that, because if I push this amplifier up to 45 volt rails, it'll run all day. But if I change the frequency, I could see a lot of oscillation. So I'm going to go with that. So for now, I'm going to build this board. I'm going to end the video here. And the next video that I'm going to come out with will be me testing this board with new transistors and inputs, or input transistors, with some measurements. And we'll go from there. So hopefully I don't spend any more gold or waste any more gold on these, hopefully. And yeah, if you liked the video, subscribe. If you have any comments, positive, negative comments, post them up. I don't care. And we'll go from there. I did spend a couple hours reading Nelson Pass's How to Match FETs myself instead of buying them online. And that was pretty fun. Thank you for that, Nelson. And yeah, have a great day. Like the video, subscribe. Thank you. Buy me a cup of coffee. I don't know. But have a good day. See you guys later.